Hello students and welcome to my channel. So in this video we will be learning the questions which were asked on the what we call current, both AC as well as DC, and they were asked on the date 29 January 2024 JEE mains. So without wasting time, we'll start this. Students, this video is in continuation with the other videos. You can please check the other videos for complete set of questions. As you know, I give you shortcut techniques as well as the actual method by which you are supposed to solve the questions. Right? So here we go. Question number 32. The electric current through a wire varies with time as I equal to I naught plus beta t, where I naught equal to 20 ampere and beta equal to 3 ampere per second. The amount of electric charge passes. Now students, as we know that current is nothing but the rate of flow of charge. So therefore, the small amount of charge flowing through a small time interval dt can be written as like this. So total amount of charge can be obtained by adding all the charges. So here current is, as you can see, 20 plus 3t. So we have to integrate between 0 to 20 seconds. So 0 to 20 seconds. Okay students, so I have placed the values of I naught and beta here. So we have 20t plus 3t square by 2 integrated between limits 0 to 20. Then, so this will be 20 into 20 plus 3 by 2 into 20 into 20. Okay students, so 400 can be taken common. We have 1 plus 3 by 2, that is 5 by 2. So 2 into 200, so altogether it is 1000 coulomb. So we'll go with the second option students. Moving to the next question, 33. The deflection in a moving coil galvanometer falls from 25 divisions to 5 divisions when a shunt of 24 ohm is applied. The resistance of galvanometer coil will be. Now this is a galvanometer coil. Okay students, this is a galvanometer. Now initially let us say I naught current was flowing through this I naught current. Next, so corresponding to that, the divisions, the deflection corresponded to 25 divisions, as you can see. But as soon as a shunt was connected, now the deflection was only 5 divisions. That means the number of divisions decreased to 1/5. You can see from 25 to 5 means 1/5. So the deflection would have decreased to 1/5. And we know deflection is proportional to the current flowing through this. So that means the current would also have decreased to 1/5. Okay students, I hope you are getting this. So that means after joining the shunt, so the current to the galvanometer decreased to I naught by 5. So the rest 4 I naught by 5 must be taken away by what? Shunt. Here I have applied Kirchhoff's first law. Out of I naught, only I naught by 5 current is flowing because the deflection reduced by a factor 1 by 5. So naturally the rest of the current must be taken away. So as you can see, in parallel connection, current varies inversely as the resistance. So here the ratio of current is 1:4. So the ratio of resistance must be 4:1. That is G by S must be 4. So G must be what? G must be 4 times of S. Here clearly they have given the value of shunt is 24. So 4 into 24 will go with the 96 ohm option. Right students, moving to the next question. Question number 33. A capacitor of capacitance 100 microfarad is charged to a potential of 12 volt and connected to this much milliampere inductor to produce oscillation, the maximum current in the cell. Now students, as you can see that initially the capacitor which had 100 micro, which is of what you call capacitance 100 microfarad, was charged to a potential difference of 12 volt. Okay. So what was the initial energy? Initial energy was initial energy in the capacitor was half CV square. Okay students, that will put it later, don't worry. And this should remain constant because after all it was connected with an inductor. So as you know, the energy keeps fluctuating between electrostatic potential energy of the capacitor and magnetostatic potential energy of the inductor. So the energy will keep fluctuating. So therefore current will also fluctuate. Okay students. Now if we don't want to know the maximum current, then at that instant the electrostatic potential energy in the capacitor must be zero and the complete energy should be in the form of magnetostatic potential energy in the inductor, that is half L I max square, where current is maximum at that instant. So applying the law of conservation of energy, because energy remains conserved, we can write half L into I max square, that is a total energy now which is in the form of electrostatic potential energy must be equal to the initial electrostatic potential energy of the capacitor. Is it students? Right. So therefore we have half L. L is clearly given as 64 by 10 milli. Milli means 10 power minus 3 into I max square is equal to half C. C is 100 micro. So 100 micro would be 10 power minus 4 into C. C V square. V square is 12 into 12. So here we go. 2 gets cancelled here students. Okay. Then as you can see 10 power minus 4 also gets cancelled exactly. So therefore we are left with I max is equal to 12 into 12 upon 64 can be written as 8 into 8 whole square root. So this is exactly 12 by 8 which is equal to 1.5 ampere. We'll go with the second option. Okay students. Right. Moving on to the next question. A galvanometer coil having coil resistance this much shows a full scale deflection for a current of 3 milliampere. For it to measure a current of 8 ampere, the value of shunt should be. Now as you know, let us slightly adjust them. So that the options are clear. Right. So here we know we have a ready-made formula students. That is, if you have a galvanometer coil of resistance G and if you want to connect a shunt with it, that is a low resistance wire, then the value of this shunt should be G upon N minus 1, where N is the factor by which the maximum current will increase. That is, the maximum current when it became an ammeter upon the maximum current when it was a galvanometer. This N. So as you can see that after becoming ammeter it could measure currents up to 8 ampere, whereas initially as a galvanometer it could measure only 3 into 10 power minus 3 ampere. So 8 by 3 into 10 power 3. This is N. So therefore shunt will be G galvanometer, coil resistance is 10 ohm. So 10 upon 8000 by 3 minus 1. So you can simply ignore this minus 1 students in comparison with 8000. So we will be left with 3 upon 800. This 3 goes up, 0 gets cancelled here. So in other words you can call it as 30 by 8 into 10 power minus 3. As you can see approximately 8 4s are 32, it should be slightly less than 4. So we will go with the third option. 3.75 into 10 power minus 3 ohm. Then moving to the next question students. In an AC circuit, voltage current are given by V equal to this and I equal to this. So these are the voltages given students. Okay. So, we have to get the average power dissipated. So as you know, we have a very simple formula in AC students. For power dissipation, we have a very simple formula. The formula states power dissipation is Vrms into Irms into the power factor. Power factor is the cosine of the phase difference between the voltage and current factors. So here you can see Vrms, this voltage, peak voltage. So peak value by root 2 in volt. Then current is 100 milliampere. So this peak value. So RMS value will be 100 milliampere upon root 2. Okay, students. And you can see the phase difference between current and voltage is 60 degrees. So cos 60 degrees half. So this should give you the full and final answer. So finally we have 10 by 4 because root 2 into root 2 is 2, 2 to the 4. So 2.5 watt is the power dissipated in the circuit. Moving to question number 37. In the given circuit, the current in resistance R3 is. This is the circuit, students. We have to find the current here. Now you can see both are in parallel, okay, and both are equal. So I can take equal current I each. That means if you apply Kirchhoff's voltage rule, Kirchhoff's first law, you get this. Okay, students. So if I apply KVL, I get I. So applying KVL, I have 2I into 2 plus 4 into I plus 1 into I is equal to 10. I have applied KVL to this loop. I have applied KVL to this loop. So therefore, I can write 4 plus 4, 10I is equal to 10. So I is equal to 1 ampere. So we'll go with the first option, students, 1 ampere. Then coming to section B. In the given circuit, the current flowing to the resistance 20 ohm is 0.3 ampere, while the ammeter is 0.10 ampere, value of R1 is. So if ampere is reading 0.9 ampere, so total current flowing must be 0.9 ampere, in which the 20 ohm resistance carries 0.3 ampere. So this will be 0.3 ampere. Okay, students. So based on that, we can find the potential difference across this. So potential difference is IR, I into R. This formula I am using, not this R. This is different. So I is how much? 0.3 ampere, whereas resistance is 20 ohm. So 6 volt is the potential difference, students. 6 volt is the potential difference. So based on that, we can find the current through this. So current through this will be 6 upon 15. So this is 3 2s are, 3 5s are, so 0.4 ampere. So here you have 0.4 ampere. So if you apply Kirchhoff's first law, you will get the current through this. So current through this will be how much? From 0.9 you will get 0.3 and 0.4. So you have 0.2 ampere. So now R1, finally R1 will be 6 volt upon 0.2 ampere. So which is 30 ohm. So 30 is the answer. Okay, students. So this is how you are supposed to calculate. Then that's all, students, in this video. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button. Thank you so much.